everyone. This is Vanessa Greer from Wilson Tool, and I want to welcome you to the latest webcast in our free webinar series, Solving Common Press Break Challenges from Short Flanges to Diamond Plate. In our webinars, our goal is to bring expert solutions to common sheet metal manufacturing challenges in a convenient online format. Please note that today's event is being recorded, and you'll be able to download the recording a day or so after this event. Also note that due to privacy reasons, the attendee list is not displayed. If you experience difficulties during the WebEx session, you can contact WebEx Technical Support at 1-866-229-3239. Also, as part of a large audience, you'll be in a listen-only mode throughout the presentation. However, if you have questions for our presenter, there'll be plenty of time for Q&A at the end of the presentation. So we encourage you to submit questions anytime throughout the presentation by using the Q&A box to the right of your screen. Just type into the text box and send. Please choose all panelists in the Send To list, or your question may not be addressed. To submit a question when you're in full screen mode, just hover over the green floating toolbar and select the question mark icon. In addition to myself, I'd like to introduce Elizabeth Graham, who will be co-hosting with me today. We'll be sorting through all your questions as they come in throughout the presentation. Now I'd like to introduce today's presenter, Steve Brown, who's the Internal Sales and Design Supervisor for the Press Break Division at Wilson Tool, where he is involved with product and process development. Steve can be reached at steve.brown@wilsontool.com. With that said, I'll now turn the presentation over to Steve.
Okay, thanks, Vanessa. Just to let everyone know, just a kind of summary of what we're going to look at today. The webinar is designed to address basic mark preventing solutions that are common, with a focus on a die that we now sell with a pivoting shoulder. So we'll talk about some of the traditional ways to handle marking, as well as some of the newer ways that we might look at. If you have specific questions, like Vanessa said, feel free to ask the questions, and we'll answer those at the end. Okay, let's move on. So let's talk about material marking, die shoulder marking, damaged diamond plate, all types of material marking, and then we'll also talk about some short flanges. Hole distortion, short flanges, somewhat the same thing, but probably looked upon as a little bit different. So we're just looking at die shoulder marking to begin with. The picture that you're seeing on the left would be a traditional die shoulder mark from your V opening. So you could probably tell how big the V opening was just by measuring from the bend line to the center of the radius. And that'd be multiplied by 2, and you'd be about what V opening to use. So we'll get calls commonly asking, why did this mark? And sometimes you can tell why it marked because the V opening is too small relative to the material. So that's a real good indicator to figure out where the V opening to begin with. And if I'm cheating the V opening down, it probably won't matter the shoulder. It'll still leave a defined mark like this. The picture on the right is showing you a pre-painted material, and it's somewhat difficult to see, but you can see a faint line from the bend mark. So that's just a steel die bending pre-painted material. And we're going to see this later in the webinar, and it's going to look a lot better. And we won't have to do a lot to get rid of that material mark. So that's kind of a summary of die shoulder marking. We see this all the time. Probably not new to anyone. And ways that we can prevent that die shoulder marking. Here again, some pretty common solutions. You could take that urethane drape that you see in the upper left, and that would go over the shoulders of the die. You would fasten it in some way to the die, commonly tape in the front and back of the die, or some sort of, we have magnets that hold this material onto the die. Lots of different ways to adhere. There are holders sold in the market, but the urethane drape would prevent most markings as well. Works well with stainless. Probably works best if you oversize the shoulder radius on the V opening. So if you have 1.5 to 2 times, maybe even 3 times the material thickness on the shoulder radius, it would help prevent that urethane from actually cutting and shearing off. So the life of the urethane would be better for the shoulder. You could oversize the V opening. If you want to reduce marking, obviously we use some time to do that. Not always an option, because if you oversize the V opening, you also increase your flange length. And flange length is sometimes stingy and just not able to oversize the V opening. You could also buy coated material. That's another thing that's common out there. It's sometimes not preferred because of the price of the material, and the price will go up. The time that it takes to remove the PVC coating from the material takes time, so it all adds cost. But it does get rid of the mark, and it's not uncommon to see this in stainless steel. So your traditional mark prevention. So I'm trying to show you another couple ways you're going to clump up urethane solutions into one slide, other than the grade that you just saw. But here's a urethane dye on the left, and it's made out of 100% urethane. It's fairly hard, but it does prevent marking. You obviously can't apply much tonnage to the urethane dye. You're going to crack the dye. It's urethane. But if you were to go 10 times material thickness or more on the deopening, urethane dye works well. A steel dye works in the middle line, a steel dye with a urethane pad insert. So now what you're really going to be, depending on your punch, come down and penetrate into that piece of urethane, and you're going to control your stroke to get your angle. And this can work well. People use this day in and day out, but this will have a tendency to wear over time and resistance to change, so you'll have to monitor your stroke and your angle, make sure you're getting consistent down, but it won't leave a mark. And the final picture that you see on the right-hand side is much the similar thing. You have a holder, basically, instead of a V opening, and you have a pad that fits in the holder. And that pad can adhere to the radius that's being bent. So you can use a variety of radiuses. Generally, with a pad, you're probably seeing a bigger radius like shown in the picture. You're probably not using an old 30 radius as often. In that case, you might just use the insert in the middle. Those are some of the urethane options that are out there, and they work well, but one rule with urethane is it breaks down and the resistance changes, so over time, depending on how hard you're hitting it, you may get different results as time goes on. You have to monitor your bend angle. Okay, and throughout the seminar, we just wanted to ask a few questions. And before I ask this question, I haven't really showed you anything with a pivoting shoulder yet, but if I said that, if I asked you, have you seen a die that has independent pivoting shoulders? We've been selling a die called E-Series. So I'm just wondering, have you even seen, as we go on with the seminar, I'm wondering a little bit about your background as I talk to you about it. So have you ever seen a die? It'll have a body, and you can go ahead and answer right now. It's just a yes/no question. Okay.
Just a second.
Okay, and okay, we'll move on. Oh, okay, 1 second. I guess we're going to wait for a couple more people here. If you haven't voted, you can just say yes or no. If you have a pivoting shoulder, got a flat top to it with a radius on the bottom, and pivoted on its own body. If I'm describing it, I haven't showed it. Okay, so it looks like just over half of you have actually seen this die, so which isn't uncommon. A lot of people have seen these types of dies, but if I ask the question, how many of you have used urethane, how many of you used the urethane dyes or increased the die shoulder radius to prevent marking, I think your percentage would be higher than 53%, but this is how many people are aware of this is an option. So, okay, we're going to stick with increasing shoulder radius of the die. So this is another option. You can take the shoulder radius of your die, make it bigger, so you have less grabbing action on the shoulder. And as elementary as that sounds, it's not uncommon for customers to call and ask, how can I prevent marking? And we find out that they're using opaque material and have extremely sharp shoulder radius for whatever reason. So just by increasing the shoulder radius, this drawing shows you on the left, it's the same V opening throughout, different angles, but an 059 radius on the first two dies versus a 119 radius. And that 119 is going to grab far left. It'll leave less depth of mark, but it'll leave a wider mark. The two V openings on the left will leave a little bit deeper mark, but a shorter mark. So you can imagine if you're painting material, that longer, less depth of mark might be real well suited for painting afterwards. If you're painting afterwards and use the gout, that's probably not going to work so well. And we probably don't see as much need for controlling the shoulder radius until you get to either painted or an aluminum or a stainless. The mild steel seems to be a little more tolerant to whatever shoulder radius you're using. So here, this is the pivoting shoulder die that we're talking about. Radius of the shoulder, the die seems to be the main source of marking. So what if the die didn't have a shoulder radius, creating a material mark? So what you're seeing here is in that blow up of the profile, the die shoulders are pivoting while they're bending, and the two lines that you see are the center line of the diameter. So from the center of the diameter is, you just got to keep the material on that center diameter while we're bending, so that the constant pressure from the bottom of the opening pushes those paddles outward. So we're showing you that it's just a nice short flange, but it's fully supported now. If you can think, and the luxury I have when you're in person is I can show you a little better example with my hand. But if you were to make a fist, and you were to take and drag material across your knuckle, I'm going to call that a radius. And the material can catch on your knuckle. But if I was to take and create between the two knuckles, I have a flat surface. If that's my paddle now, I can drag material across that, and I'm going to flat against flat instead of a point in contact with a flat. Hopefully that made sense, but real good way to prevent marking. It won't get rid of marking, but it'll help prevent any kind of marking to depth for sure. Zip mark is here's another option for arc screw bending, and we're still using the same type of die. It has an inserted shoulder, and you're seeing that with the blue color on the top of the paddles. What we're trying to show you is that paddle version with a product called Zipmar. It's a type of urethane that's been sold for years on the punching side, and we've adopted it over to the bending side. So you can clean and degrease the surface of those paddles, apply the Zipmar, which are already pre-cut, and now that picture that we saw at the beginning, you can see that on the right-hand side where you see the before picture. And throughout the PowerPoint, you'll see the little smiley face. Those are the better-looking products after we've addressed the material marking. So if you use Zipmar applied to V-Series black paddles, that's the result that you get on the left-hand side. No additional protection. It's a painted material, and you can't even tell where the bend marks are. There are no bend marks. So there's nothing to clean afterwards. There's nothing to remove. You don't have to pay for the additional protection on the material. So it works really well. Okay, our second question, I'm wondering if you own a die that has pivoting shoulders. So 53% of you said that you've seen these out in the market before. Now, of the people listening, how many of you actually have owned one of these dies or currently own this? So anytime in the past, it seems like, I'm just going to make a prediction, we'll see where all the numbers come in, because this is probably the most official poll we've ever taken. But commonly, a lot of people know about this style of die, and less people actually own it. So if you could just answer yes or no to the question, whether you own in your shop a die with pivoting shoulders. So just so you know, with what we're doing today, some of this has been taken, this is actually a snippet from fab forums that we've been posting over the past year or so, once a month. And if you like these types of things, we actually have something coming up in August. On August 20th, we have a technology forum coming up. It's a one-time deal. I'm saying this information comes from the fab forum, but the technology forum is a one-time August 20th attendance. So if any of you are interested in that, maybe we can give a little information of that towards the end and get in contact with us. So I made a prediction that less people would own it than they've heard about it. And guess what? 19% of people that are taking the poll actually own the die. So you know about this, you've seen it, you've seen some of the benefits. 50% of the people probably haven't seen it, but you know, some of the questions would be why wouldn't you call it something to do? So let's just keep rolling with the PowerPoint. Let's look at some more marking issues. Diamond plate, very common to see bent in the industry, and what you're seeing here is on the left-hand side, that diamond plate where the arrows are, you can see this is traditional marking that you get on diamond plate with a traditional die and a shoulder on it. So you're going to take your diamond plate that has a protruding tread to it, drag it across the shoulder. As it drags, it makes a huge mark. So your options are, you can put backer plate to this, and then throw away the backer plate each time. But if you're bending longer bends, you're bending high volume, that's constant scrap that you're creating. It's a lot of work to put it on the die. It costs a lot of money for the scrap. So on the right-hand side, if you use this pivoting shoulder die line using B-series black, you'll get no marking. You won't be able to tell where it marks, because now it's the same theory. Instead of having a point being dragged across, you have a flat that diamond rests on. And as the diamond gets pulled down, it's not being grabbed by a shoulder. It's just riding on a flat surface. So you end up with a beautiful product. So if you have diamond plate of any kind, I don't know of another method of bending it that would be as easy as using that type of die. So, and here's just a picture to kind of illustrate what we just talked about. On the top, you see a traditional shoulder with protrusions there, and then you drag in and grab onto each one of those and mark the material. And on the bottom, you see your B-series black, and the protrusions are just resting on a flat surface, and they draw into the V and they make their bend. And the third and final question, if you answered yes, so I'm really talking to 19% of the people that are listening out there. If you answered yes, you own a die with pivoting shoulders, what are the most common uses? So if you could just, from the list that you see, select all that apply. So you've got short and disappearing flange. You've got holes close to a bend line. Still a short flange, but probably still viewed upon as something different because of the stretch. The hole could stretch. You've got material marking, and I've brought it out into 4 different categories only because of material type. And then you've got general bending. You just use it. You don't use this for marking all the time. Sometimes you do, but you've left it in because you can do a range of material with these as well. I don't have to change V openings. I can do the same V opening, same die, and I can do a range from 18 to 16 gauge, let's say. So I just leave it in for general bending. So if you can click all that apply, there's a good chance that you might use it for multiples here. Okay, in about a couple more seconds here, we can just wrap up your selections. Okay, so here's what you told us and how you use this die. Of the 19%, holes close to bend line, 29% of them use it. Holes close to bend line, 29% for general bending. So you just leave it in there. It works fine. You don't have to take it in and out and do a die change. You've got material marking, and 14% use it on aluminum. 14% use it on, well, second, expand here. 14% use it on mild steel. And I don't have anybody listening, it sounds like they're using on tread plate. So maybe that's an opportunity for somebody listening out there. And we don't have a lot of people using it for short flange, which is another real common usage. And you'll see that in the upcoming slides how it works with short flange. Okay, moving on. So let's get into the hole distortion and short flanges with this die. Materials with a hole tend to distort and drag over the shoulder radius. So what you're seeing is a large hole right next to the bend line on the left, and you're seeing a small hole next to the bend line on the right. What you also see on the right is a flange that disappears down to almost no flange. There is a little bit of a flange, but it's almost all radius, so you really don't have any flat there to catch on to the shoulder of a traditional die. So if we just look at hole distortion, here's a before and after picture using, on the left, the V-series black. On the right is a traditional die, and it doesn't come out as well in a picture as it does in person, but that part on the right actually has a hole that's stretched and puckered right next to the bend line. So, in the picture on the left, it's the exact same part, bent with the exact same punch, and there's absolutely no distortion. As a matter of fact, you can't even tell where the bend line is. Everything lines up. So if you had holes, let's say you're making multiple bends, and your fastening hole is at the end, you can't distort the hole, and you need accurate bends all the way along. So these guys help achieve that. Short flanges, now you're seeing the same picture. A couple of those are the same picture on the right. You see the blue picture, and you're seeing that flange disappear really down to no flange. And if you were to bend that part on the right-hand side, or even the part on the upper left, and you use your traditional die, you get a real distortion at the end. It falls off the shoulder, and you probably continue to make the bend because enough of it is on the die, but you're going to see some distortion. It's just going to want to open out. And here you're seeing a bend that's almost perfect. You still even see a little bit of distortion at the end of that disappearing flange picture. Very slight, but probably about a fifth of what you would see if you just used a regular wheel. And in the upper left, you don't see any distortion. And on the window cutout, you don't see any distortion because it's supported by that flat paddle. So a great solution for short flanges and cutouts. Here again, it's the same picture, just some reinforcement. But you've got to keep your flange on the center pivot point. There is a limitation. These aren't miracle dies completely. You can't take no flange and bend it. You still have to have a flange. If you get any smaller than this, you're probably going to come to a wiping application, hopefully with a thinner material. But you do have to have a required flange. And here's a couple more pictures. On the left-hand side, you see your traditional die, and you see the square has a short flange to it, and it hasn't caught the V opening, so it really just doesn't bend. It falls into the V opening. And on the outside, the same thing. So on the right-hand side, you're seeing the exact same part bent in the V series, and you get a perfect part every time. If you could be in person, we actually bend these up and hand these out. It's in your hand, and you can see the difference. A couple more parts. This one has a rectangle that's been distorted. Really see the distortion here. That rectangle goes right down to the radius, the bend radius at the end. You'll also see a flange that disappeared to no flange. And on the bottom, it's perfect. Okay, so I told you about this die. Let me show you the die. We've got a video. And this is actually off our website. So if you were to want to go back and look at this, you can sure watch it again. And I'll just let it run. If I talk, it'll interfere with the audio from the video. So I'll just let this run. And if you have questions, submit the questions. We'll answer them at the end. Those of you that are operating a press brake, you can appreciate what's going on here. But there's a real pucker there. Now that pucker is coming from a traditional die, where the V-series is going to leave it perfectly flat. Okay, one thing that you saw in this video is you saw that material crack, and you saw the big difference in inside radius. And the reason that's happening is when you bend with these dies, when you bend with a V-series black, and the paddle pushes around the material, it actually wraps it around a punch bit. So you can tend to control your inside radius a little bit more with the V-series black with your punch than you can with the paddle. So that's a little bit different. If you're out there air bending, that's a little bit different change for you. Okay, so that's kind of the first point on this slide. When you use a punch set, it's got to be more acute than the angle being bent. So if you're using a 88-degree punch to bend a 90-degree bend right now, that might not be the best usage of your punch. You could try it. Depending on the material type and thickness, it might work fine, but you don't want to create resistance against the punch. So your best choice is to go as acute as possible relative to the bend that you're bending. So if you're bending 90 degrees, a 30-degree punch would be your ideal choice. Practically, it certainly doesn't need to be 30. You can go with 75, you go with 85, 86. Those would work fine as well, but you want to get away from that angle as much as possible. You also want to consume at least 60% of the roller. I'm going to call a roller or a shoulder insert what you're seeing on the top, the paddles. And I'm going to want to consume at least 60% of the width of one of those paddles, because on the smaller versions, if you don't, it's going to want to buckle a little bit. It doesn't pivot as well. So we can help control that in the application. If you have questions about that, the sales desk can help answer those questions. Account for the roller seams when you're bending stainless. One thing, it works really well for all the flanges, but when it comes to the marking, there is no mark left virtually, except between seams. If you're bending, let's just say you bend display cases. If you're bending a display case and you look down the length of it like a 2x4, you're going to want to be aware that in between each one of these inserts, you can see a real smart distortion. Not a mark, but a distortion. And it's seen in the light, but you can't even hardly feel it. So that's one of the limitations. You have to know that that's out there, but otherwise, this works really well. And from here on out, that's just a quick overview on some of the common ways that you're dealing with marking. A solution with that, the pivoting shoulder die, something that is out there, it's in the market, and not enough people probably use it. You could probably leverage this better. But we'll take a look. Are there any questions?
Yep, we did get one question in so far, so I'm going to have Steve answer this. But while he's answering that, if you haven't had a chance to answer the question or to ask a question, please take the time now, send in your questions, and we'll try to get to them.
Okay, so here's the question. It's a good one. Can you bend sharp and radius bend the same die? Is there a die available for the 375 radius? So the first question, can you bend sharp and radius bends with the same die? The answer would be yes, because you would control that with the radius through punch. You may have submitted that before. I just got done talking about that. But if you were to bend 060 material with an 8,000th radius, you're going to get a fairly sharp radius. Now, if you were to bump that radius up to 120, I'm going to call that a bigger radius for that relative die and material thickness maybe, you would change your material, you would change your punch, but you would use the same die because it would wrap around that punch tip. And then, is there a die available for 375 radius punches or radius bends? Okay, what you need to do is you just have to make sure that the maximum outside radius doesn't exceed the point where we can no longer pivot the paddle. So it's got to stay inside that center diameter. So you'd have to take 375. We would add 2 material thicknesses to that. So we get basically your outside most radius that you're bending, and ensure that bends. So yes, it depends on your material thickness, because I don't know your material thickness, but that's how you can calculate it. There are 3 different sizes available, and you can also order it up in an adjustable version. So there is a way to take a 375 radius and use a pivoting shoulder, yes. Okay, one more question. What are the thicknesses that can be bent with these dies? Okay, three different sizes of dies that each cover their own range. So the model 1, or the smallest, would be your thinnest material up to 060 or maybe 070. You'll see our charts call it 060, but in many occasions you'll be able to do up to 074. Then you take your 074, and that would be a little bit thicker than you'd want for the Model 1, so we might go to the Model 2, and that would give you another range. It'd be 074 to 135, I believe, 10 gauge. And then your Model 3 is going to go 10, anything heavier than 10 gauge up to about 250 or even 313. And after that, you're probably getting into more of the larger, you know, maybe even an adjustable type of die to accommodate what you're trying to do. And these are all extremely high tonnage rated dies. Actually, they're probably rated more than the press brake is, so you have to be careful that you're not overdoing it. You're not going to hurt the die for the most part. Your tonnage displaces differently on these dies. They displace in that radius that it's pivoting on instead of a point like it does on the shoulder of the die. So commonly, we'd rate the Model 1, you're bending in a small little vehicle, that's rated at like 40 tons a foot. So you don't have any dies that are that little that are rated 40 tons a foot in the precision world, at least. We could make them that way if we beefed up the body. So hopefully that answers that. Quite a few questions rolling in here now. Is there wear and tear? Is the wear and tear on this similar to standard dies? The inserts are hardened, so generally speaking, no, because you have a sliding action rather than a grabbing action. So it's another advantage. You have a hardened shoulder. It's going to be 55 to 60 Rockwell speed scale, and it does have a tendency to slide. It's not grabbing. So I would tell you that you probably will get better wear life on these dies than you would on standard shoulder radius. What is maintenance and tool life? Kind of goes together with the wear. The maintenance depends totally on your usage, but the more debris that you have, the more that you're going to want to do some regular maintenance. We have a customer right now that we've sold a large order to, and their maintenance routine is going to be once a month. They pull these apart once a month because they could go longer, but if they do, they could start getting inaccurate parts. So they'll pull these out, clean them, and lube them once a month. So that's kind of an extreme one. I don't know that our 19% out there that are actually using these probably pull them apart that often. So they're pretty well self-contained, but they are moving. They do open up. So you certainly would want to have some sort of maintenance based on the usage. Probably, but you think about it, I mean, I don't know if you would contrast it to a regular die. If you have a regular die, you have maintenance to your die too if you have that kind of debris. So I don't know that you're going to have any more or less, but there would be different maintenance than we'd be used to on a stationary die. So another one, max thickness. Maybe we talked about that a little bit. The max thickness on the shelf items would be 313 or 250 thousandths thick. That would be most common. There is not really a limit to the thickness. We can figure out a solution to make it bigger. You offer Black Series die sectional. They are also sectional. They come at a 500 millimeter length or a 550 millimeter length sectional. So that would be your traditional standard length for it, 550 sectionalized. You get the pieces with that. And if you get to the bigger die, if you get to the Model 3, it's actually a 455 millimeter length. So they are offered sectionalized. Can you get Zipmar from you, or do you need to go to someone else? The Zipmar strips, we have actually had those manufactured and cut to the width of the inserts on the die. So what you're able to do is order a 100-foot roll of Zipmar and cut it to whatever length you want. You can bridge the gap over several dies, or you can make it the size of the insert, whatever your preference is. It's sold by the roll. So it's actually probably one of the most underutilized things that we sell right now because people don't think to do it. Even at our own sales desk, we have to keep thinking of that as an option because it's such an inexpensive way to not need to ever protect your die. And it stays on really well. It's an adhesive. You have to clean your die well, but it's a very good adhesive. We've done our own testing in-house. We actually have a difficult time getting it to come off. I don't know that we ever have. It lasts a long time. And length of dies, and we kind of talked about this, is sectionalized, and we have the 500 millimeter solid, which is 19.6 inches. Okay, so I think those are all the questions regarding the die. We've got one unrelated to die marking a little bit. let me just read this real quick. We're bending some panels currently that come in warp due to the number of punch louvers in them. Okay, so a bunch of louvers into one sheet. Maybe it's fairly thin even. Can we keep them fairly straight and square? How do other people deal with warp issues? Probably another topic, and it might, I guess I don't know, I'm assuming that you make these in the press brake. They're made in the turret. The answer might be a little bit different as well, but in the press brake, you have some spacing issues, some height issues, and you have pressure pads that you can put into the die. So if you have a simple louver, and that louver is the starting of material, possibly it's just a louver. Maybe it needs to have more surface pressing on the material so that you can lock the material in before you make the louver, which is a little bit different type of die than your traditional louver. But that's what you have to do if you want to gang them off. Okay, one more question. How do the dies affect the bend allowance? Okay, well, the dies won't, your radius produced is going to affect the bend allowance. So we know now that the punches affect the inside radius. And so as your inside radius changes, your bend allowance is going to change as well. So just like if you go back 20 or 30 years, there's been a huge movement to air bending. And if we ever talk to somebody that's still coining, and there's still plenty of people, and we're trying to make that transition, that's a great thing to focus on, because if you have drawings made, if you have blanks that are made, if you have adjustments that need to be made to the blank that count that different bend deduction, you're going to want to do that, because it will change. Right? It's not air bending anymore. It's a different method of bending. But there again, you just have to weigh out that change worth it, because you don't have to do other things.
Okay, I think that's all the questions that have come in so far. Thanks for sending all those in, you guys. I want to first just take a moment to apologize for the audio issues that we had today. I know the sound wasn't great coming through to you guys. It is a little bit dependent on bandwidth, so it's unfortunately not 100% in our control, but we're going to try and get that squared away before the next webinar. So first of all, I want to thank Steve Brown here, our presenter, for sharing with us today, and thank all of you guys for joining us. And for those of you who maybe didn't get a chance to send in a question or think of one later, or for more information on the ideas presented in this webinar, please contact your Wilson Tool sales engineer, or you can visit our website at wilsontool.com. You may also reach Steve directly again at steve.brown at wilsontool.com, or for general questions, you can email Elizabeth or myself at marketing@wilsontool.com. We'll be sending you guys an email in the next day or two with a PDF of today's presentation, as well as a link to the recording of this webinar. You'll also be able to find the recording to this, as well as all of our previous webinars, under the Media Center tab on our website. Now, as Steve mentioned, we are holding a Press Brake Technology Forum here at our facility in White Bear Lake on August 20th. We'll be presenting along with LVD Strip-It, Radan, Prima Power, and Cincinnati on the latest advancements in press brake technology. It's going to be a great event, and we hope you guys can all make it. And we promise the audio will be crystal clear at that event. You can find more information how to register on the news and events page of our website. And again, you can email marketing@wilsontool.com if you have any questions about that. We hope you found today's webinar helpful, and we look forward to working with you guys in the future. Have a great day, everyone. Thanks.